Hello everyone, myself Vignesh Swami, a graduate research assistant in Binghamton University pursuing CS575 Design Analysis and Algorithms, and this presentation would be for the final project in our Design Analysis and Algorithms course. To quickly wrap up the agenda, what we will be seeing in today's presentation are I have chosen two non-trivial algorithms. So basically, it is a star search algorithm and a graph coloring algorithm. Today's presentation will be seeing what is the pseudocode and how I have developed the algorithm and how I have developed a web application in order to demonstrate for this demo for visually better, and what are the inputs and outputs and some of the sample test cases which some from easy level to the higher complex level. We'll be seeing all the test cases as well in today's presentation and the demo. Moving on with the demo. A star tree. So A star tree is nothing but a search algorithm. So this A star is a search algorithm, which is primarily one of the very fine-tuned, optimized algorithm. We have multiple such algorithms, basically like Digictras, DFS, BFS, and multiple algorithms are there. Even though we have multiple algorithms in searching the shortest path or like optimal solution for such algorithm, but still we'll use the A star algorithm. I'll tell what are the drawbacks why we are not using the Digictras algorithm or any other algorithm. Even though Digictras algorithm is very famous for showing the shortest path, finding the shortest path, but still it is lagging in a particular area where uh, it is like spending more time or wasting a lot of time for exploring the directions which is not necessary or which is not promising for the algorithm it needs to be. So this is a drawback why we are not using digital algorithm, even though it is going to find the shortest path or the very optimal solution for finding the shortest path. We have multiple other things including like, let's say, greedy breadth first search, or the greedy BFS algorithms, which is also like promisingly it will explore only the promising directions only. It will not go through all the other directions and waste the time for exploring the other directions, but it will only explore to the promising directions, but still it won't find the shortest path. So if we compare these two algorithms, it is like one is having one advantage and other is having the other advantage, vice versa, one is having another drawback and another is having another drawback. So then came the A star algorithm. So A star algorithm is nothing but the modification of the Dijkstra's algorithm, so which currently in this algorithm I have been implemented. So I have basically taken the digital algorithm and I have tried to implement in a way in JavaScript. I have redesigned the algorithm from the existing implementation, and it has been like designed in such a way it is like most optimal in finding the shortest path between the given nodes. Also, here how the algorithm works, the reason why A star is really like a very effective and optimized algorithm. A star uses both the calculations between like the actual distance from the start of the node, and also it calculates and tracks the estimated distance till to reach the destination or the goal. So that is how it is going to track both the sides of the nodes. So that is how it is like really it is designed in a way such that it is like really optimal. So here let's the design is like based on this formula f is equal to g plus h. So f means the total cost of the node here. So what is the total cost it would take for reaching from the start node to the destination? And what is g here is nothing but the distance between the current node and the start node. So it means like, let's say we are in a particular current node and we already came from the start node, and this distance is calculated by g, and h is nothing but the heuristics distance. This is the very important concept in this entire algorithm. The heuristic distance is nothing but the estimated distance between the current node till the end of the destination node or this end node. So this distance has been calculated. So by calculating the difference between the start node till the current node and the current node till the end node, we'll be able to achieve the total cost. So by this we'll be looping and finding which is the total best cost of the node to be traversing from the start node and the end node. So by this it will be achieving a path line. That path line would be the shortest distance. And to make a note on this, the complexity here completely is like exponential since it is depending upon the heuristics of the given graph. Let's proceed. So the same explanation how I have given is like given in the pseudocode as well, which I'll be further going through in the code implementation and the further demo in today's presentation. But to just note, so f is equal to g plus h is the implementation, how we are going to use it. I will explain the same in the code implementation, how the pseudocode I have converted to the implementation. So moving on with the other algorithm is graph coloring algorithm. So here the graph coloring algorithm, the main problem statement why I took this algorithm is we need to calculate. Let's say we are given a graph and we need to find how many colors can fit the given graph. With how many number of colors a given graph can be implemented with different colors in such a way that with the constraint given that two adjacent nodes will not be having the same colors. That is a constraint given. It means like in the same adjacent sites you will not be having the in the adjacent edges you will not be having the nodes with the same colors. And here the approach I use is greedy algorithm. So there are like various ways we can use this, like backtracking or dynamic programming, but I have chosen greedy algorithm in order to make how it can be like made very effective. So the pseudocode is mentioned here. So here, let me explain it through a demo, but let me walk through a pseudocode quickly. So the pseudocode basically tells like we will be given an input matrix. It's nothing but the adjacent matrix to calculate how we will be calculating from the given graph. Let's say a node has been connected from 0 to 1. And if there is a connection between 0 and 1, it is going to be calculated. The same matrix would be added in the adjacent matrix. So this is basically called as adjacent matrix. The vector representation of the graph is called the adjacent matrix. So we'll be having this as an input, and now we'll be counting the degree and we'll be finding the maximum degree. So based upon the degree only, we will be able to see and analyze, and we'll be able to apply the colors to the given set of matrices in nodes. So with the different nodes, we'll be first trying to fix first color in the list of the colors which we are already having, and we'll be trying to color the first node. Based upon that, we'll be again going through a criteria. So this is the main process here. So this criteria is basically like we'll be looping by sorting it, and we'll be able to find what is the next color it need to be added. So it is going to such a criteria logic way the adjacent nodes are not having the same color. This is the logic it is being placed in this main process here, which I'll go through during the demo. So once this is like sorted and a particular color is applied, the color will be removed. The reason is we are making sure this within the same adjacent nodes we are not having the same color. So we'll be removing so that the next color will be filling in the exact matrix. And here the complexity is completely depending upon the number of vertices and the edges. Here the vertices are nothing but nodes. So these are the landing page, algorithm page which I have designed. I will be explaining very further, very detail in the demo now. I hope this presentation is clear. Moving on with the demo. Okay, this is a React application I have designed in order to make sure that the React is very powerful and it is like we are able to design. Yeah, sorry. We are able to design different algorithms here. So these two buttons basically are here for A star algorithm and the graph coloring algorithm. So the A star algorithm, when we click it, it will navigate you to the different test cases and how the test cases are designed and how the code has been working in the backend. So to demonstrate it first, let me demonstrate a quick example and then we'll be able to understand how the code is working. So let me go through a test case. Here the input is like 10 cross 10 grid, and at this point of time there is no start node or the end node. I'm just going to click test case. So in this test case we are able to see that the grid size here is 10 cross 10 and the start node is 0 0 comma 0. So this is the very start node of the 10 cross 10 grid here, which is available here. If you count, there will be 10 lines and 10 columns, 10 rows and 10 columns. That's it. So the end node is 3 comma 0. So this is a very simple example I have just taken in order to make sure it is working from the simple to the complex levels. So here, the heuristics is being calculated. So as I already mentioned, this is like a very simple example, and so the calculation of the nodes are being very simple and straightforward. Here, there is no need of the algorithm to just traverse through the other nodes or the neighboring nodes. So it is going to go through the straight rows, and it is going to calculate the heuristics by calculating the total cost of the node. And so this is the very efficient way, and it is going to calculate the next cell in the given grid. And this is how it is going to loop till it is going to reach the end node. So if you see 0 comma 0, the first one, 1 comma 0, the second row first one, 2 comma 0, the third row first one, on the last row to it has reached the node. So this is how it has been designed. So and let us go through some of the examples, some complicated examples. So it is going to be a start node is at here in the beginning, and the end node is at the end of the grid. So it means like it is the longest travel for the thing. So we need to make sure which is the shortest path here. So in order to find the shortest path, our algorithm which I have designed is going to give this is the output which has been given by the algorithm which I have designed. It is not a static data, this is like a dynamic data. I can show how it is dynamic. So we can see that this is the row and the column 0 comma 0 here, and the end node is like 9 comma 9 end node. So this is the algorithm which I designed to show the start node and end node. So once the algorithm, when I click the test case, it has called the algorithm and it has looped, and we have found like 19 arrays. So these arrays are nothing but like the different the heuristics values, how it has started, and which is the highest degree value to calculate the heuristics function, and total cost. So here 0 comma 0, 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4, similarly it goes to 0 comma 9, and it means like 0 comma 9 is here. Now the target current node is here. So the same thing has been given as an output here, which I just shown. Make sure this is not like a static data, and it is from coming from the algorithm which I have designed. And from here it is going to start from 1 comma 9 here, 2 comma 9, 3 comma 9. Similarly, it reaches the node till 9 comma 9, and this is the effective algorithm that can be used for the A star. And this applies for multiple different test cases. As you can see, like different test cases, when I clicked, I am able to generate like a different array set, which is having like the best case solution to reach to the particular node 7 comma 4 here. This is 7 comma 4, 0 comma 0 to 7 comma 4. These are the paths where it is going to take the shortest distance. Let me walk through the code parallelly at the same time. And this is the code which I have generated for in the React application with the JavaScript. So this algorithm is basically like having all the inputs, test cases, everything designed here. So based upon the click, let me walk through the examples. Yeah. So based upon the clicks, we are able to click all the buttons here, and based upon the buttons, we are able to uh, get the distances. So these are the three buttons which I have clicked on for the three test cases. I have given like a random start node and end node. Make sure whatever input we are changing, it is going to work as the algorithm is working. So, and moving on to the algorithm. So here, this is the very first while loop. There are basically like two while loops where it is starting and it is going to check the heuristic distance as I mentioned. So here, as I mentioned in the formula, f is equal to g plus h. I'm going to get the initial node from the given list, whatever we have trying to get from the matrix as the given input. So the input matrix we have got, and with the input matrix now we are able to traverse through, and we are trying to loop in such a way that which is a maximum efficient way. And once we are able to calculate the total cost, we are just again continuing till it is like reaching the end node. So we are trying to reach to the current neighbors. So all the nodes are once all the nodes are currently visited, then only this loop will be breaking out, so that it means like it has reached the end node. And this is a heuristic function. Basically, heuristic function is nothing but like a Pythagoras theorem, how we'll be getting the we're taking the hypotenuse between the two different sides, so that we'll be able to calculate the distance. And these are some of the node functions which I have created in order to find the relative cells. I hope AEST algorithm is clear. Moving on. So I'm just going to the home landing page again. So from here we are going to go through the graph coloring algorithm here. So the graph coloring algorithm I have designed in the same fashion, such that there are different test cases. At this point of time, at the example I have just taken, like this is the adjacent matrix. So this is like a matrix implementation. So the graph coloring algorithms. So in this matrix implementation, we will know like where exactly the nodes are. So this is the representation of the nodes. So in order for making easier to understand, I have just made it like visually pictorially depicted here. So A, B, C, D, these are the 4 nodes, and there are like multiple test cases I've created. Let us walk through like some of the complex examples as well here today. So this is, as I have already mentioned, this is like a sample test case. This is the given graph by default. So this is going to be the graph that is given, so that as per the problem statement which I have explained in today's presentation, we are going to make sure our algorithm is going to take the graph as an input, and with this graph we'll also get as an input like number of colors. So these are the two inputs. We are getting the adjacent matrix graph, and the number of colors is going to be 3. We are going to create this graph, and once we are able to create this graph, we are going to try whether we'll be able to fit in the given number of m colors. Let's say the 3 colors here at this particular case, 3 colors can be fit in such a way that it is passing the constraint that no two adjacent colors are having nodes are having the same colors. So this is the problem statement which I have taken and I have worked on using the greedy approach. And by the algorithm which I have developed, I am able to get the solution. Like my algorithm is able to generate and give the output. Like let's say node A is like a red, okay, node B is blue, and the node C is yellow. Similarly, D red, and similarly E is yellow. So this is how it has been like created. So if you see here, these are the adjacent matrices. As already mentioned, these adjacent nodes here are having 3 different colors. Okay. Moving on to the next adjacent nodes, B, E, D is having different nodes, different colors, and this nodes and D, B, D, C. This is also having different colors. And overall, when we are making sure the whole connected graph, we are able to see that it has been able to fill with 3 different colors only. So it is like a success case for the problem statement. And similarly, for complicated examples as well, I had tried to check with my algorithm, and this one of the complex example I was able to figure out. And with this given graph, and with the, I'm trying to fill with the 3 colors. With this 3 color algorithm which I've developed, I'm able to successfully pass the 3 colors. So this is also like passing. It means like each adjacent nodes are having only different colors, and it's not being the same repeated colors. So if you see, the output is being changed for this case. Node is A is equal to yellow, blue, red, yellow, blue, red. So this is how it has been designed. And finally, it's like satisfying the conditions for the criteria of the graph coloring algorithm as well. So let me walk through the code for this. So in this, rather than the designs and the coloring styles I have developed, I have created some of the HTML stylings in order to make the web application. Here the input seems to be like, these are 3 different test case buttons. This is the graph which I have given, and this is the nodes. Let's say for this particular graph A, B, C, D, E, I'm giving like 5 nodes. So in this 5 nodes, these 2 are the input parameters, and this is going to go and call my algorithm which I have designed. So this algorithm is like a simple algorithm where I'm trying to calculate. Initially I'm going to assign like a set of numbers, let's say like a list of colors. Here I'm giving like 4 colors in order to make sure m color with the 3 is going to work. So that even though if I'm going to give 4 colors in my color list here, this color list is having 4 colors. Even though if I have 4 colors, it is not necessary for my algorithm to fill all the 4 colors into the given graph. So that is what I was trying to prove it. So all the m colors are being mapped, even though if there is a 4. If you have seen the output here, only like I have, it has been used like 3 colors, basically yellow, blue, red. That's it. So this is the 3 colors is been used. So here it is like as discussed in the presentation, it is going to be based upon the adjacent matrix as an input, and it is going to take the degrees here. So based upon the degrees, when the highest degree is there, it is going to consider it, and it is going to start filling. So this is the main process where it is going to try to update the colors. So as I mentioned, the very first node will be like filled with the given color list which you are already having. If the first color has been filled in the given graph, let's say here A has been filled, and it is going to make sure in such a way that all the index respective, it's going to be corresponding to the adjacent matrix A, C, B, or let it be A, E, C, or not having the same colors. So for that, what we need to do is, it is going to slice it. As in JavaScript it's called a slice, but in regular usually it will tell like a remove it, or like delete it. So we're going to delete the color which has been inserted for the particular instance alone, so that for that particular adjacent matrices, these three nodes will not be able to again fill the same yellow color, as we have already filled yellow color in this adjacent matrix here. We will be able to fill the other colors. So this is how we are able to develop this algorithm. So this is how it is like slicing for the very first item, whatever the colors already we have filled, and finally we'll be able to sort it. And this is just to print the output in the console window here, as seen here. So this is algorithm which I developed for the graph coloring algorithms. I hope today's presentation was informative and helpful. Thank you for granting me this opportunity.